Welcome to the MS Dev Show, episode number 159. This week we talk with Rimma Nehme about Cosmos DB, learn to code with a fidget spinner, and what if companies interview translators the way they interview coders?
This episode of the MS Dev Show is brought to you by Expose, the market leader of .NET and Java APIs for file business formats. Natively work with DocX, XSLX, PPT, PDF, MSG, MPP, image formats, and many more. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications. Check it out today at raygun.com.
This week we have Rimma Nehme, GPM in Azure Cosmos DB, previously an architect in Azure Cosmos DB in the open source software analytics team at Microsoft. She also jump-started Poly-based technology and shipped it in SQL DW, SQL Server PDW, and SQL Server 2016. She's also a PhD in computer science from Purdue and has an MBA from the University of Chicago. Welcome.
Thank you. Thank you. Great to be here.
Yeah, very impressive background as well. Very cool.
Thanks.
So Carl, what's going on?
Well, I just want to remind everybody who hasn't heard or is still on the fence about it that we will be at that conference in the middle of Wisconsin at the beginning of August, and we want to meet you there. So if you have never been to a conference like this, it is an amazing place. It's in fact, I was at the first one, and that was where I really kind of opened my eyes to like how awesome going to conferences are and how welcoming the developer community is. So if you want to kind of meet other developers, learn just tons of new things, it's a polyglot conference. So if you want to hear about JavaScript and then maybe some Ruby thing and follow up with Microsoft technologies, it's all there.
Yeah. So we're 1 month out, which is pretty crazy. And it's interesting what you said too. That's what you made that conference made you like conferences, which is funny because a lot of people listening are probably like, I hate conferences. So this is a conference that you will enjoy.
And not only that, but it's at a water park. So bring your family.
Yeah.
The family can go off and do the water park during the day. You can chill with them at night, or you can do the after conference stuff. There's always family friendly things. They have tons of family tracks. They have a board game night that's actually sponsored by a local board game company. So there's always stuff to do. It's always a blast.
Absolutely.
And then in addition, we would like to just remind those who haven't, check us out on our Slack. You can sign up at slack.msdevshow.com, send yourself an invite and join us. We want to talk to you there.
Yep.
Just a nice way to just keep up with each other in between podcast episodes.
Yep. We're starting to get closer to critical mass there. So what do we have for the comment of the week?
The comment of the week gets a developer small business license for Expose Total for .NET, which includes all of the Expose.NET products in one package. And this week, we actually got it on a comment from Channel 9. Mike Sage says he really enjoys the show, but he must admit for multiple reasons. Of course, there's the excellent content and always fun news. But he admits that he usually falls asleep to the show. If his son gets up early on Saturday or Sunday mornings, he tends to be noisy. And while he can sleep through anything, his wife can't. So he'll take him to the basement, turn on the podcast, and after the news, he falls asleep.
Wow, that's great, I guess. Wait, we should play right here. I should play some like lullaby music for him.
That's after the news, Jason.
Yeah.
And he says, also spaces. How can anybody endure tabs?
Ouch. Yeah, that's very cool. And I also want to point out that people probably noticed that we have a second sponsor now. So we have Raygun as a sponsor, and obviously we have the ad and the pre-roll and the mid-roll. But I just want to do a kind of a special thanks to our sponsors because they make it so that we can do this show and do it right. So really appreciative. So definitely go check out the sponsor sites and go check out what they have.
Yeah, just so anybody, to dispel any myths, Jason and I aren't raking in any cash from this. This goes back to pay for whatever our costs are, but then we also give the rest back to you guys. So if you are coming to that conference or meet me up anywhere, I always have stuff to hand out. So
I was gonna say I'm broke over here. I got my tablets and my drone. I'm like trying to figure out if there's any expensive stuff I can grab. No, this is yeah, you're absolutely right though. Okay, so let's move on. Let's talk about the news. What if companies interviewed translators the way they interview coders? I love this article. This was great.
Oh, this was a great article, and we're not going to go through it in great detail, but I definitely want to link here for you guys. I mean, I think we've all been through those interviews where you go in there and you know it's a development position. Maybe let's just say it's a web development position, and you go in there like, oh, let me code this an implementation of a stack on the whiteboard over here,
or a linked
and
list.
And then you're like, well, what does this having to do with me making your website pretty? And you're like, I mean, yes, it's something that we've all done, probably, learned it in school, but what does this have to do with the day-to-day pieces? And this is just a nice satirical piece, putting this same, paradigm into another profession. And it makes it really make this interview technique look silly.
Yeah. So it probably makes sense for Rimma's team actually, because they're like super smart, like down, they're worrying about all those little details and performance and things like that. So do you do a lot of interviewing, Rimma?
I do, especially lately.
Yeah.
Yes.
Exactly. It's something, it's a necessary evil, but I suspect you're not asking them about things that were relevant, a decade ago and not relevant today.
Well, it's actually the fundamentals are still relevant. They're just now running at a different scale,
Yeah. I was going to say, your team is probably kind of an exception to this, but, you look at a lot of these like full stack developers and ask them, code out on my whiteboard this linked list scenario. It's just like, this is so far away from, what they're going to be doing on a day-to-day basis.
True. Yeah.
Yep. Okay, these maps reveal the hidden structures of Choose Your Own Adventure books.
I really like infographics, and this is kind of taking, one of the things that I grew up with, those Choose Your Own Adventure books where you could read a few pages and then you make a decision on which way the story should go. And I didn't realize it, but it's kind of a thing to actually make maps that represent the different paths in a book.
Yep.
And not only that, but this article actually goes into comparing the graphs that are generated of the earlier books compared to the later books and how much more complicated certain ones are. And these make really interesting visualizations. They kind of show you how many pages before each decision and kind of the trees that are there. And some of you even have loops in them. So it's really graphical and in your face on how the paths can take shape.
Yeah, by Balloon to the Sahara has 48 decision points. That is crazy. And then there's one of these that only has like a handful of decision points. So it's kind of interesting seeing the extreme values there. Yeah, 8 decision points. So this is kind of a really weird connection, but I was actually at dinner with Ryan Crocker the other night. And I don't know, he started talking about Choose Your Own Adventure books, and I mentioned this article to him, and he was freaking out. He's like, "You got to send that to me." And as you know, he used to do some work with DocumentDB, so just kind of an interesting connection there. What do we have next here? Learn to code with this fidget spinner.
Fidget spinners are all the rage, at least amongst my kids and all of their friends. And I'm sure pretty much everywhere right now where fidget spinners can be shipped to. They're pretty cheap and they're entertaining. But somebody made a fidget spinner out of an actual circuit board that you can program yourself. And I just thought that was really cool. If you go to this page, you can see like all the details on it, and there's a link to another place where you can buy it, and I think it's about $40 US.
Okay.
And they also have like a classroom pack where if you want to get a bunch of them, you can get them at probably a discount. I'm assuming. I didn't do the math on it, but I think I'm definitely going to get one at the bare minimum because I know a few of my kids are interested in development, and even if it's just kind of tweaking a few things instead of doing like any, trying to do it, something from scratch, I think they would find it really interesting.
Yeah, to do like different light patterns. So it's got three wings, obviously, or whatever you call those things, three arms. One has an Arduino. The other has a battery. I don't know how they balance this though, because the other one just has it has a row of LEDs. So I don't know if the weight is correct. Actually, now that I look at it, I can see. Do you see that there's a battery underneath the other wing? So I bet you that's how they balance it. Okay, well that mystery is solved. But very cool, yeah. Because Arduino, there's such good tooling out there, and it's so easy to reprogram that thing and have different light patterns. So that would be pretty neat to experiment with. Okay, so let's talk Cosmos DB. So I guess let's just kind of start at the beginning for somebody who isn't familiar with it. What is Cosmos DB?
So Cosmos DB is Microsoft's globally distributed multi-model database service. The way I put it, it's the best thing that could happen to the entire data space. It's
that's it, huh?
That's it pretty much. So it's really, from the ground up, as a cloud service, as a database service, it's designed to exploit the cloud's design center and the economies of scale. So that means it will give you the global presence. So wherever Azure is, wherever the cloud is, Cosmos DB will be there. And fundamentally, it's there to address the need. Your users, your devices, your bots are everywhere. And typically the stateless front ends, when you're building an application, are also everywhere. Now, databases have been traditionally lacking behind. They've been primarily focused on being a local database. So Cosmos DB is trying to address that pain point and that need and disseminates your data wherever your users are, and then try to serve them the local data, regardless of their geolocation. So as a result, you get very highly responsive experiences because the data is where the users are. And it's obviously also by being natively built-in cloud service, it tries to exploit all of the elasticity, scalability, of the cloud itself. Also, the lowest total cost of ownership, because behind the scenes, we use the commodity hardware at the massive scale, fine-grained multi-tenancy from the ground up. So we can take hundreds of customers, put them on a single machine, or put thousands of them across the cluster. And with all of that, we bake in resource governance across the entire stack. So the utilization of machines and clusters is super, super optimal. And the net result is we can provide the lowest possible cost that, for instance, IaaS hosted managed offerings just cannot beat this. And then from the developer's point of view, also, we try to meet the developers wherever they are. And we will talk a little bit more in this podcast. This is the multi-API, multi-model approach, where instead of being dogmatic and religious about one and only model or one API, we try to embrace the most popular APIs and the models and really make them work and shine on top of, Cosmos DB stack.
Mm-hmm. So years ago when I started at Microsoft, I remember saying hey, SQL Server is I don't want to say incompatible with the cloud, but at the time it was one of these things where, you install it somewhere and it didn't have the properties that you're talking about. Now there's, SQL database and that's changed a little bit. But when I started, I was talking to people and I'm like, we need a database that will basically do all the things that you described. And they were like, no, you can't really do that. That's difficult or impossible. And I was like, there's a lot of smart people at Microsoft. I'm sure we could build this. And, I just had to wait a few years, and look at that. You smart people built exactly what I wanted. So this is very cool.
So that's precisely it, actually. To give you a little bit of history of Cosmos DB, it's actually 7 years in work in progress.
Oh, so you guys were working on it when I was even saying that.
Yes. So actually, it started out in the late 2010, internally known as Project Florence. Mm-hmm. And Dharma Shukla, who is the founder of Cosmos DB, and he's a distinguished engineer and now general manager of the service. He actually also noticed, the internal first-party customers, the likes of Bing, Office 365, MSN, Skype, they were building these large-scale, internet-scale applications, and they needed the database backend that could scale with their applications. And they were trying to use relational databases, and they didn't work for them. They were trying to build it in the house, and it also took most of their attention away from the applications into their backend database. And so that's precisely why this project and this product was born, to try to address the needs of massively scalable, large-scale applications and try to outsource all of those problems that typically they were facing. And this means running at global scale, being highly elastic with respect to both storage and throughput, provide this very, very low latency to give the near real-time response experience, and then also navigate the consistency choice spectrum and also have the SLAs, because fundamentally, the way I put it, we are in the service business, and with that comes a certain set of expectations about performance, latency, throughput, availability, and the consistency as well.
So you've talked a bunch about performance, and I know at Build they really mentioned like how massive a scale can be achieved with Cosmos. Can you give us a kind of a sense of how big that we can scale this out in all the different directions?
Sure. Planet scale. That would be the shortest answer. Now, to give you a little bit more insight, so Cosmos DB is what internally is known as a foundational Azure service, or layer 0 or ring 0 service. That means it's automatically available in all Azure regions by default, including sovereign and government clouds. So as Azure adds new regions, we will automatically be rolled out there. Today, we are already running across 34 plus regions. That means you can come take your database entity, for instance, a table, and make it span the entire planet. Behind the scenes, the multi-region replication is fully transparent and automatic, and you can associate any number of regions with your database account at any time. So the way we call it, it's known as a global distribution turnkey. And to give you the analogy, it's almost like when you come to a car, right? You don't really need to know how the car works behind the scenes, how the engine works, how the wheels rotate, how everything is interconnected. You just turn on the key, the car starts up, and it gets you from point A to point B. And this is the similar idea with the global distribution. You come to a world map, you see all of the Azure regions, and then you just select on all of those regions that you want to associate with your database, click Save. With a single click of a button, your data gets seamlessly replicated across the globe, and you can query it at any point in time. And the beautiful part here is that you don't need to do anything with your application as you're adding new regions and you're expanding across the world. All of the endpoints between the database and the application is logical by default. So that means the applications don't need to be redeployed. If, for instance, a failover occurs, your application will continuously be highly available. But applications also can access the physical endpoints if they need to, if they want to even optimize for performance further. But by default, it's designed to be globally scalable, very, very highly available. You can also go and dynamically set priorities to the regions. So if, for instance, if a failure occurs, it will actually fail over in the order of those priorities. You can also, one of the other unique cool things that we provide is you can actually go and simulate regional disaster via an API and test the entire application stack for, should something happens, how would your application actually react? And we're the first and only service that offers comprehensive SLAs for latency, throughput, availability, and consistency. And when you actually go and simulate these failures, you can actually go and see that the SLA doesn't change. So this gives you sort of, the idea that it's planet scale. At the same time, is also it's really, the scale that we're talking about, the behind the scenes, the engine is designed to be horizontally scalable. So a single machine is never a bottleneck. You can take a single table and scale it from a few gigabytes to petabytes across many machines and regions. the other fundamental difference is the system is designed to independently scale storage and throughput. So you can start out, for instance, with a few gigabytes, scale it to petabyte. You can also seamlessly, transparently scale the throughput itself, for instance, from tens to hundreds of millions of requests per second across multiple regions. And you can actually dynamically change, depending on the region, the time of the day, what is the throughput that you need. So for instance, let's assume you have an application that is running globally. If it's a daytime in, say, in Asia, and it's a nighttime in North America, you can dynamically actually fluctuate the throughput that you need, because the volume that you will expect will be different based on the geolocation and the time of the day. And the customers pay by the hour for the provision throughput that they need. We also support the requests, both requests per second and requests per minute for different workloads. So this ensures that you never have to provision for the peak. You can basically go and optimize for stable workloads, but then have a reserved pool of resources to just address these, occasional spikes. If, for instance, maybe somebody tweets about your application and all of a sudden you have a flood of users, bombarding your database, you can automatically accommodate for that without, really over provisioning to accommodate for these surprising spikes. And again, the customers pay only for the throughput and the storage that they need.
Yeah, this is incredible. I mean, it sounds like you guys really thought about everything. So very cool.
Yes, it really was born. It was customer backward driven. Yeah. Approach to trying to address these points. And the other sort of thing to think about, and this is for me, like as a techie, I find it really incredibly exciting, is that the way the architecture was done is that really without any dogma or religion about how the systems should be built. It's really working backwards from what the needs are and what is the most elegant and flexible way to go and build it inside the system like Cosmos DB.
Yeah, I think that the example of being able to test the failover, like that's something that the partners I work with, they need that. Like that's always a requirement. And usually it's something where somebody will build something, or there's this database product and it's like, hey, they want to be able to test this failover. And it's like, that's an interesting use case. Like we should figure out how to do that. But
yes.
The fact that like you're just like, yep, we got that, right off the bat, I think is really cool.
Yes.
And then, so one of the cool things about Cosmos DB, and one of the things that was announced at Build, was the fact that you have all these different interface types. So, previously, you could use like a DocDB interface, and then there was a MongoDB interface, but now there's also table storage and GraphDB, and I think we should talk about that more deeply. But just the ability to be able to use those different interfaces, I find amazing, because I've created some Azure functions where I just needed to do some simple state management, and being able to use the Node.js MongoDB client, which it's super easy to use, just a few lines of code, I can be using Cosmos DB, which is really cool. So, I don't know if you want to kind of walk through these or kind of compare, like, what are the capabilities of these different interfaces?
Sure. So I think fundamentally, the way I put it, the beauty of the Cosmos DB is actually that globally distributed, horizontally scalable, very, very flexible stack with, consistency models, comprehensive SLAs. And then everything that we put on top of that becomes orders of magnitude differentiated. So one of the things that we also, as a team decided, fundamentally, no data is born relational in the physical world. It's born in whatever shape or form it was born. Yeah. So as a result, we added the native support for multiple data models. So the database engine operates on this concept called Atom Record Sequence, or ARS-based type system. All of the data models are efficiently translated to this ARS, and then APIs and wire protocols are supported via these extensible modules on top of it. So, for instance, behind the scenes, basically, the instance of a given data model, whether it's a key value or a document or a graph, is materialized as trees. And we currently support a graph, documents, key value, column family, and more data models will come. So that was kind of like one of the fundamental decisions made there. And the key insight there is that because it's built on this core stack, by default, for instance, if you take a graph, it automatically becomes globally distributed, horizontally scalable, with guaranteed low latency, with consistency models, with comprehensive SLAs. And then on top of that, another decision was made, let's put native support for multiple APIs, formats, and wire protocols to meet the developers where they are. So what that means is, what does this actually enable? Well, number one is no recompilation is needed. So that means in many cases, the applications that are already built, whether they're running already on-prem or even in another cloud, they don't need to be recompiled. The other insight is that now developers get better SLAs, lower total cost of ownership. They get the enterprise-grade security and amazing capabilities without requiring changing a single line of their application code or data access layer. But even further, developers can still continue leveraging their existing open source software tool chains and ecosystems and their expertise, and now tap into the whole power of the cloud, which is very, very powerful. And for us, we didn't need to go and re-implement, the entire tool chain and ecosystem of all these tools that developers already love to use. So we are leveraging, and the developers can continue to leverage their existing tools that they love. Lifting and shifting from on-prem to cloud becomes very, very, simple. There is no also fear of a vendor lock-in because, these are open source software, popular APIs that developers continue to using. And it also allows you to use the symmetric on-premise and cloud database development. So for instance, you can use, MongoDB on-prem, but then you can seamlessly migrate onto Cosmos DB on Azure. How are they different or, the same? Most of the APIs, they are, the goal here is that we provide the native support for those APIs. So each one is designed for a particular set of use cases or scenarios, or maybe it's a preference for the developers. For instance, if you're developing against Graph, chances are you will come in from, open source using Apache Gremlin. And in this case, you can go and natively go query the graph that lives inside Cosmos DB. If you're developing against a document data model, you can come in and use native document DB API, or you can come in through a MongoDB API. So in that respect, we embrace all of them. I view them as like different front doors into this, beautiful garden of Cosmos DB, or I don't know what the better analogy to give. And you can come in through whichever door that makes the most sense for you. Now, the other key insight here is that if you look at most of the applications that are being built in the cloud, they tend to be polyglot in nature. So what you will frequently notice as the backend architecture, you will see an app, and then you will see one database for transactional processing, another database for key value, another database for documents, another database for graph. And so you see 4 or 5 services in the backend of the application that creates a very, very rigid and complex architecture. What it also forces developers to do is actually spend most of their time on the back end trying to fine-tune these 4 different database services for performance, for instance, for consistency. As a result, the total cost again increases, and then most of the productivity of the application developers get spent on the back end rather than focusing on the value of their application. By having something like Cosmos DB that actually consolidates and enables these multiple APIs, you simplify the backend tremendously. And then from another view, you can look at it. Each API on top of Cosmos DB is almost like a managed service by itself. So MongoDB API on top of Cosmos DB, it's like managed Mongo on Azure. Gremlin API on top of Cosmos DB, it's like globally distributed managed PaaS service on Azure. Then Table API is like managed key value store on Azure. So each API gives you the experience of a managed service that is tailored for that data model for that API. But the beautiful part is you can come in through any front door and use it in the same app and get the same value.
So what you're saying is, if I start off with, this Mongo interface, could I in the same application against the same Cosmos instance, come in from a Gremlin interface as well? Can I mix and match that granularly, or do I have to stick to one once I start using it?
So the backend, remember I told you we're
Yep.
using this ARS model. So in that respect, all of the data models are actually represented by the same type system. So you could access, for instance, if you have a collection of documents, you could access it as a collection of documents, or you could come in through the Gremlin API and treat it as a graph. And then every document is treated as a node in your graph.
That is really cool, because when I originally heard this announcement from at Build, I know I got this impression. I'm assuming a lot of other developers did too. That hey, these are just 4 different databases that are all unique or whatever. But it is the same database, it's the same data. Like you said, there's this common infrastructure that's abstracted away from us, and I think this is what's really cool right here is being able to do that, consolidation and reuse the way that you have.
Correct. And behind the scenes, you can view it as a human readable JSON. So I can actually go see my documents as JSON document, or I can see my graph represented as a bunch of JSON documents. And you can potentially actually go take a JSON representation and convert it, for instance, from a document into a native graph representation. So in that respect, the way the system is built, it's built for that very, so much flexibility that it literally enables you to go and converge one data model to another without much friction.
Aspose offers a powerful set of file management APIs with which developers can create applications which can create, open, edit, and save the majority of popular business file formats. Their product range supports a multitude of file formats, including Word documents, Excel spreadsheets, PowerPoint presentations, PDF documents, OneNote, Outlook, Project, Visio files, popular image formats, and many others. Aspose produces APIs for .NET, Java, and the cloud, which can be utilized in almost any modern language available today. Visit aspose.com for a free 30-day no limitations trial, and if you get stuck, message the friendly support team for help. All technical support is offered free of charge. And remember, if you are a lucky winner, you will receive a free developer small business license for Aspose.net, a powerful toolkit for working with Word documents in your applications.
So, I know whenever you originally create it, like it asks you what type you want to create. I think that's still the case.
Correct.
But yeah, go ahead.
So the reason why we've done it is, when you come through the portal, you pick the API. This is designed to really tailor the whole experience through the portal to that native experience of the data model.
Which is what most people want anyway.
Correct. So for instance, if you are going to work with the graph, actually, when you come to the Data Explorer after you create that graph and you pick Gremlin API, you can actually visualize it inside the portal as a graph and then click on the nodes and edges. And we sort of try to tailor the whole experience natively to that data model. But when it comes to your client application, you can go and access it via other APIs as well. But I always say, with great power comes great responsibility. With that respect, sometimes you should also come and expect that if you designed it as a MongoDB collection and you're trying to access it via Graph API, there could be some things that you don't expect. So
yeah, I don't know what you would expect if you did that.
So that's what I'm saying. With great power comes great responsibility. But we will certainly, again, the way the stack and the system was designed is to be very, very flexible.
Okay.
All right. So now that we have this really awesome, flexible new storage technology with Cosmos, does Microsoft have guidance on when to use that versus its many, many, many other storage? Because we still have SQL Azure, there's still table storage and blob storage, and I mean, there's just many different things. So, is there like kind of, one or a couple places that we can look at to see what best fits what we need to be developing?
Yeah, I think this is a work in progress right now to, for instance, show a decision tree, to give you the link. But my suggestion or recommendation would be, if you are building a net new application, you should always start with Cosmos DB, because chances are it will address your needs. It will be far more robust. It will be far more flexible. It will address also the complexity of the data that you are dealing with, the size of the data that could potentially grow into terabytes or petabytes. In that respect, it's it's very flexible and future-proof. It also gives you very low latency guarantees. So it's the service that gives you less than 10 millisecond read latency guarantee for the 99th percentile of the requests, and it gives you less than 15 milliseconds for the index write latency, also at the 99th percentile. And then, if and only if Cosmos DB doesn't work for you, first of all, you contact me and our team, and we'll find out why. And if and only if that doesn't work, then you go and try out other technologies. You've mentioned also, for instance, Azure Table Storage, which is another NoSQL offering on top of Cosmos DB. So we've just announced the public preview of the Table API on top of Cosmos DB, which gives you basically the premium table experience. With secondary indices, geo-replication.
Ding, 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 ding.
Yep. Comprehensive SLAs and so forth. And right now we are actually building out a stack that is storage optimized, and we'll have the offering that is storage optimized offering, which will be the equivalent of Azure Tables. So what that means is that the two services will converge in the near future and onto Cosmos DB stack, with giving you both the storage optimized experience, which is the equivalent of standard tables today, and the premium tables, and then the throughput optimized offering as well.
Very cool. Very cool. So, at Build, and actually it was you. I was going to say Microsoft, but like you, we're really emphasizing the scalability and the consistency types. So I know we talked about quite a bit about the scalability, but I think we should talk through like some of the different consistency models. So like, what are they and how do those work?
Yes. So programmable data consistency is a fascinating area, and I tried to translate some of that excitement at Build, and boy, did it become cool. Who knew that data consistency could be that exciting? But it is. So the way I put it, databases today are divided into two categories. Number one is one camp basically provides you with two binary, very extreme choices, strong versus eventual consistency. So, for instance, if you want, perfect consistency across the globe, across all of your regions, you can get it via strong consistency model. That will come typically with the price of higher latency, because you need to make sure that all of your replicas are synchronized. And lower availability, because until that happens, it's as if your database is unavailable. So most of the relational databases give you strong consistency, and other systems as well. Versus another extreme choice, which is eventual consistency. So in that respect, it's really optimized for low latency, high availability, but all hands are off with respect to consistency. So this is one camp. You basically red pill versus blue pill. You have to pick between these two extremes. Now, there is another camp where it leaves everything for developers to configure. One perfect example of that would be Cassandra. So you have to basically deal with things like read repair, hinted handoff, quorum sizes, replication topologies, and then the developer literally has to have a PhD in distributed systems to go and figure out, well, how do I go configure all these settings to ensure that my durability is right, availability, latency, and consistency are all not compromised. So the developers basically are facing this tension, or like this really, really challenging problem. Like, how do they make this very, very precise trade-off between consistency and availability? For instance, if a failure occurs, consistency and latency, and this is very important for a steady state of the application. How much latency are you willing to tolerate, or does your application actually need, so that your users don't run off to some other application? And consistency and throughput. And this is very important, for instance, for the total cost of ownership, because the more throughput you need, the more it will cost you. But then, how much consistency do you actually also need? So Cosmos DB is the only database service out there on the market today that gives you 5 well-defined, precise consistency models to choose from. And they are strong consistency, which gives you the linearizability guarantees. It gives you eventual consistency, which is out of order reads, just like the two binary extreme choices. And then we also looked at 40 years of distributed systems research, and we've distilled a set of intermediate consistency levels that are practical, well-defined, and developers can actually reason about them. So they are bounded staleness, which basically means your reads lag behind the writes by k prefixes or t time interval. Session consistency model, which gives you monotonic reads, monotonic writes. You can read your own writes, and writes follow the reads. And then a consistent prefix, which basically means updates are returned by some prefix of all of the updates with no gaps. So the key thing here is that given these 5 well-defined consistency models, developers can now just pick the right one for their application specific for their needs. And you can change that choice anytime via an API or via the portal.
That was going to be my next question. Yeah.
Yes.
Yeah. Because the thing is, like you were talking earlier about these, Cassandra and like all these knobs that you need to turn. And I find that like really annoying because whenever I start on a project and it's probably just me, but I have this, I have this big problem where, when I have all these decisions to make at the beginning, I just, kind of lock up and I'm like, I don't know. I just don't know yet. Like,
I just want to get going.
Yeah. Let me write my thing and figure out the requirements as I'm coding and then I go pick this. So I like that because I'd probably set that, sort of slider. I'd probably set it like right in the middle.
Yep.
Just to kind of maintain sanity in my application, I'd probably feel fine there. But knowing that I could, move it right or left would be great.
You can change your choice anytime via an API or via the portal. You can go override it on a per request basis. It's very, very flexible. So you definitely, you can make your changes anytime you want. And the key thing actually, so this is so to give you some insight, behind the scenes, we're looking at the telemetry. How do developers actually use these programmable data consistency choices that we enable? And so to give you an idea, only 3% use strong consistency. Only 4% use eventual consistency. These are the two binary extreme choices.
Really? Okay.
And everybody else is in the middle. And this is something that nobody else on the market actually offers today but Cosmos DB. So, and this is a very strong customer signal about the value that they're getting out of these programmable consistency choices that they can reason about and change at any point in time.
Yeah, that's interesting because that middle option seems like the one dead in the middle seems like a great trade-off that I suspect would work in my application. Like I wouldn't anticipate too many issues. Eventual consistency. I think I'm just kind of going through the thought process. When I look at that, people say they call that never consistent. So like that would keep popping in my head. Like, okay, that just seems like anarchy. And then the always consistent, that just seems like, that's how they did in the olden days. So I kind of see why people go, they just stick right in the middle. That makes the most sense to me.
Yeah.
Yeah. So, I mean, you talked about how easy it is to change these consistency types, like in the portal and in code. And I was kind of wondering, kind of moving to kind of a different aspect, how, when I look about globally distributing my application, do I have the same flexibility? How does choosing where it gets distributed to, how does that work? Is it?
So this is where the global distribution turnkey comes in. You literally come to a world map and you see the regions and you pick the regions. It's the world map. Coming back to click, and then
I can figure that out.
Yeah,
even I can do it.
Even my 4-year-old daughter can do it. So it's it's the fun part to clicking on the map, and then you just click save, and then the data gets seamlessly replicated into those regions. You can do similar thing directly through your application. Just specify the regions where you want your database to be, and it will get seamlessly replicated. And you can again change it at any point in time.
Okay. And
I think that's really cool because in the past I've known a lot of places that have written a lot of custom code many times over to do the same thing, and all I have to do is click on a map and I get it all those features for free. That's kind of mind blowing.
Actually,
exactly.
I have a specific question for that then. If I have let's say I have a whole bunch of data sitting in like US West, and I go and I check, I don't know, somewhere in Asia, for example. So I check that. My data gets replicated. Then can I uncheck US West?
Yes.
Okay, man, you're right,
So it's
Carl.
also good for migrating.
That solves
Yes.
a huge problem because I've been
Yes.
talking to, I won't talk about the type of data, but I was talking to a couple big companies about like video specifically, and you have this whole issue of whenever you store the video, we were talking about this architecture and going in all these details, and I said, okay, what happens when somebody moves and they're like, oh boy. They're just kind of freaking out. They're like, because basically, they're gonna move to Asia and they're gonna be trying to like view all this video from US West, and it's not gonna be a good experience. So that's awesome.
Correct. So, sometimes I joke a little bit. Cosmos DB is the database that enables you to beat the speed of light.
Mm-hmm.
And, people get intrigued by it, but the idea is kind of related to what you just mentioned.
Mm-hmm.
For instance, if for instance, I have a database in West US and I am writing all of my data there, and let's assume it's a local database. It's not globally distributed database, but most of my users are in Australia. And so if they want to go and read my data that I'm updating from West US, typically what would happen is, the users would come in Australia and they would do the round trip to the West US. And purely, by geographic distance, the speed of light, roughly it would be about 200, 300 millisecond round trip.
Mm-hmm.
Now, with Cosmos DB, you can go and enable Australia with a single click of a button. The data will get seamlessly replicated. And when the users from Australia try to read that data, the data will be served to them locally, and it will be served to them in less than 10 milliseconds. So this is what I say, 200 or 300 milliseconds with the speed of light if it were not globally distributed database versus under 10 milliseconds.
Yeah.
So
it's like a CDN for your database. Trademark.
It is. It is. Similar in spirit. Yes.
I'll give you that one. So we did. You did mention like the SLA a few times. So like, what is the actual SLA, or is that kind of complicated? Is it just a specific number?
Yeah, no. So the SLAs, this is really, really something that is stand out. Something that we're very, very proud of in Cosmos DB. So, the way, as I mentioned earlier, fundamentally we are in the service business, not the software business.
Right.
So when developers build their applications, typically, most of the existing cloud services, whether it's Azure or AWS or Google Cloud, typically they give you an SLA with respect to high availability. And so at that point in time, it becomes a little bit of a game, whoever gives you the highest number of nines, whether it's 3 nines, 4 nines, 5 nines, or whatnot. So we've looked at it and we sort of stepped back a little bit and asked, again, a very, very simple but fundamental question. What do developers really care about? And, they care about other things when it comes to globally distributed databases and, the things that are on their mind. As I mentioned before, latency versus consistency trade-offs, availability versus consistency trade-off, throughput versus consistency trade-off, and, throughput versus latency. It's almost like you can do the matrix here. And so the decision that, and something that we've been working very, very hard on to build a very robust stack is to enable a comprehensive set of SLAs. That means it's the only service today in the cloud industry that gives you the SLA for latency, for throughput, for consistency, and high availability at the 99th percentile. So you can come today to Azure Portal, you can click on the metrics blade, and you can actually look at your runtime metrics with respect to the SLAs. And you can see how your database behaves and compare and look at it per region, across regions, and then, just get that peace of mind that you don't need to go and hire an army of consultants to go and fine-tune your backend or optimize for availability, or if something goes wrong in the middle of the night, your application will be down and it could be business ending, proposition at that point in time. So this is the first service in the cloud industry that gives you comprehensive SLAs that are actually financially backed. Mm-hmm. So it's a very, very powerful, and from the customer backward point of view, peace of mind, and, that their application will be up, available, performant, serving consistent data all across the globe to their users.
Don't wait for users to report problems. Raygun gives you complete visibility on errors, crashes, and performance problems affecting your end users. Replicate issues in seconds rather than digging through log files or having to rely on users to report errors or crashes. Raygun gives you a window into how users are really experiencing your software applications, supports all major programming languages and platforms, and integrates with your current development workflow tools too. There's a free 14-day trial, and it takes minutes to implement, so start resolving issues in your application and check it out today at raygun.com. So I was looking at, during some of the research for Cosmos DB, and without even looking for it, it mentioned quite a few times in several places how inexpensive Cosmos is to run. So what is the pricing model for this right now?
Yeah, so the pricing model is based on provision throughput, and you provision at the granularity over second. We have this notion, we call it like a logical currency, I call it like a Bitcoin for Cosmos DB. It's called request units, or RUs. So the request units are basically the abstraction for the resources for you to run your database. And so what you do is you come in and you provision your throughput using the RUs units. And you say, for instance, I want to run 100,000 RUs per second. You provision that throughput and off you go, and you pay for what you need, and you pay at the granularity of an hour. So what it allows you to do is basically optimize for the workloads that are running on your Cosmos database. And then I mentioned earlier in the podcast, we've added an additional capability called RUs per minute, which is you can think of pool of reserved resources that you can go and amortize at the granularity of a minute. So for instance, if you're running at 100,000 requests per unit, then somebody tweets about your application, and all of a sudden you have a wave of users going and pounding, a particular geographic region, there's a lot of activity. You can, without over provisioning, you can basically seamlessly tap into that RUs per minute budget, satisfy those requests, and without, increasing your cost. So in that respect, we also have done total cost of ownership comparison against other open source popular NoSQL databases, and also against DynamoDB. This is available online, and the listeners can go and read through that paper. We basically have taken the paper that DynamoDB folks published in 2012, and we've done a similar benchmark against our own Cosmos DB stack. And what we've observed is that on average, Cosmos DB could be anywhere 5 to 10x more cost effective than other popular NoSQL databases on premises or running as an IaaS hosted version. And remember, why is it so? I mean, first of all, as I mentioned before, Cosmos DB deeply exploits cloud core properties and the economies of scale. So the commodity hardware, the fine-grained multi-tenancy, end-to-end resource governance, optimal utilization of resources, we can go and optimize the backend and then pass on all of those cost savings to our customers. The other thing is also, the superior elasticity. You can provision the throughput, scale up and down within seconds. So that allows you to reduce the cost of ownership during non-peak times. For instance, open source NoSQL clusters deployed on cloud infrastructure, they offer limited elasticity in that regard. And on-premises deployments are simply not elastic because you already bought the hardware, you're already there, you're kind of stuck with it. The other thing is also because it's a managed cloud service, you don't need to have any administration or DevOps. You don't need to employ a DevOps team to handle deployments, maintenance, scale, patching, and any other day-to-day tasks that you would require if you're deploying it on-prem or doing it via hosted cluster on the cloud infrastructure. And as I mentioned before, also again, Cosmos DB fundamentally is a cloud-born database, so it is cloud optimized, and something. For instance, if you bring in other open source NoSQL software, they are typically not aware of the differences when, for instance, a node or VM goes down, or if there is a routine image upgrade to a VM, or for instance, if there are some other intimate, like, premium disk properties that could be exploited even further. So that gives us a little bit more of the native advantage by being, again, cloud natively born service that is hard to imitate.
Okay. And it looks like the actual storage itself then is 25 cents per gigabyte per month. And that's SSD backed, which is pretty impressive.
Correct. So the engine itself is, as you mentioned, it's SSD backend. Also, the engine itself, the way it's designed, it's completely schema-free and schema-agnostic. And this is, fundamental difference, for instance, compared to traditional relational databases. Typically, when you come to SQL or Oracle, you have to first identify what is the schema that you are going to need, then put your data into that schema. Then you need to identify a set of indices that you need to go and create in order to optimize for the workload that you're going to go and run against that data. In Cosmos DB, in some sense, we've reversed that paradigm. First of all, at global scale, schema and index management is hard. And I can't emphasize how hard it is. Yeah. It's like, it's just sometimes really a conversation non-starter. So in that respect, the database engine is fully schema agnostic, but still the schema extraction is built in. So if you're building, for instance, some analytics on top of it, or you're using some tool like Power BI or Tableau or whatever else that needs a schema, we can do the schema extraction and supply it up the food chain. But the other fundamental difference is that we provide the automatic and synchronous indexing of all of the ingested content. So this is the reverse of the relational databases where indexing is opt-in. In our case, you opt out. So we will automatically go index everything so that your workloads run very, very fast.
So is there any things in the future, any roadmap items that you can share with our audience today?
Yes. So one of the things, so at the build, we've announced, the preview of the table and graph APIs. Yep. So obviously we will go and we will GA those in the coming months. And then the story of, multi-model, multi-API will become richer and richer and richer. So what you would expect is in the near future, we'll have more APIs coming and more data models coming on top of Cosmos DB stack. So it's not a hard leap to imagine that at one point we'll have H-based APIs that will give us the synergy with all of the open source software analytics stacks.
That'd be amazing.
Because H-based is part of every Hadoop stack. Also Cassandra APIs. So this is to meet the Cassandra developers on-prem if they want to come and take advantage of Cosmos DB stack. Other things that we're working on is we are also adding the capabilities to bring in the data, bring in the workloads that are more storage optimized. So currently the stack is throughput optimized. So it's optimized for the workloads that need very, very low latency. You need to optimize for the throughput. But in some cases, you might want to bring the workloads that are heavy in storage, but you might not need to run that many transactions on top of them. So this is something that we're also working on the storage optimized offering. The other thing that is on our roadmap is adding NC compliant SQL on top of Cosmos DB. So that will meet, all of the relational database users and allow them have a similar experience on top of Cosmos DB. And we are also working very closely with Azure Functions team to build a very strong connection and integration with, Azure Functions to give, to give the serverless architectures as a first-class citizen and use Cosmos DB as a de facto standard for data in those serverless architectures.
Oh, that's cool. Because that's exactly what I had to do recently. So that's perfect.
Yes. And more and more synergy with with, as I mentioned, IoT. IoT hubs, Azure Functions for serverless. You'll see a lot more integration with analytics stacks. We already support today native Spark connector to Cosmos DB. So you can actually, and this connector understands the physical structure of our backend. So you can actually push the computation down close to where the data lives. In that respect, you can run your Spark SQL jobs or whatever else you might be running in Spark against Cosmos DB data. We are also working with the Azure Stack team to provide Cosmos DB on Azure Stack. So lots and lots of exciting things coming.
That's it? Just the roadmap is 10 other products worth of features. So
yes, well, this is the exciting future of the cloud and Cosmos DB and everything else.
Yeah,
it enables you to do. And again, being a globally distributed database, meeting the users and the data where it's born at that geolocation, and enabling this flexibility and fluidity in the performance. Fundamentally, it enables a lot of very, very powerful scenarios. And, data is the least common denominator for all of these use cases. And it's very, very exciting.
Very cool. Okay, so let's move on. Is there anything else you wanted to mention before we move on? I think we covered it pretty well, but I don't know if there's anything else you're dying to tell us.
I think so. I think what I would suggest to everybody, the call to action, if you haven't played with Cosmos DB, by all means, go play with it. One thing I wanted to mention.
Sure.
So if you are developing or you want to try to develop your application, we have also a local version of Cosmos DB, which is a high fidelity experience from the developer standpoint of view. You can go and download it as bare metal installation on your developer box, or you can actually get it as a Docker container. Cosmos DB local emulator, and start developing without incurring any costs, and try out the system itself, and then migrating it to the cloud will be very, very seamless and similar experience.
I love using it through the web because it's like a button click away, right? Give me one of those.
Yes.
And then you just start using it, and
yes.
And I think if somebody's used something like Mongo, I would just start with this is just my personal experience. I would start with the Mongo client library, and I found it so easy. I mean, it was literally 3 lines of code, to connect and then to read some data and write some data. It was that simple. So me using it from Azure Functions that way was super easy, and the code was just really, really simple. There was no noise at all.
Yes.
Yep. So Carl, what is the dev tip of the week?
So I have 2 of them. The first one is in Chrome. A lot of time when you're doing web development, you want to reload a page, or you might want to reload a page and empty the cache, or you might just want to do a hard reload all the assets. Well, in DevTools, there's a lot of different options to do them kind of manually that are hidden. If you have the tools open, so if you hit F12 and you just click and hold the reload button right up next to the URL bar, they'll actually drop down those different options for you all there. So you have one little spot to do all the different kinds of reloading that you might need for your development. And I know that I've seen that in the past, but it always seemed kind of random when it showed up and when it didn't.
Yep.
The trick is have the DevTools open.
Yep.
It shows up every time.
Yeah, I don't know why they don't enable that all the time. And because it gives you, there's like a soft reload, hard reload, and then I think empty cache.
Reload. Yeah.
Hard reload, yeah. Just make it so that maybe even like with a longer delay, because there's times you want to do that. But I guess they consider that a developer feature, so you have to have the tools open.
Yep. So if it seemed kind of random for you in the past, just open the DevTools. It'll be there every time.
Yep.
My next dev tip is a VS Code one. I am a fan of the multi-cursor mode. So they actually have a ton of different ways that you can add multiple cursors. So you can either do the Control Alt and arrow key and then like add arrows up and down, or you can just do Alt click and you can actually combine those. One of the problems with that though is sometimes you get a little over aggressive. You hit the click too much or arrow over too much and you get too many arrows. If that you just hit Control U and you keep doing it, they'll go away in the order that they appeared. So
That's cool.
If you're a fan of multi-cursors and like me are overly aggressive, you can undo those.
Oh wow. Yeah. I saw a demo online. I'd have to find it, but it's basically showing off all the multi-cursor functionality. And man, if you get good at this, it might have even been like a Pluralsight video. If you get good at this, man, you can just be like a demon. It's just and like changing code everywhere, and it's amazing.
Well, I use it heavily to edit the show notes. So, we do it in OneNote and we export it to Markdown, but the exporting process isn't clean, and it's nice to have clean Markdown for our DocPad website. And this makes it super easy to just edit that and make it perfectly clean Markdown.
Okay, so Rimma, there's a game that we play. What I need you to do is pick a number between 1 and 4 inclusive.
2.
2, okay. Would you rather be born with an elephant trunk or a giraffe neck?
Giraffe neck. I can see a lot further than.
Yeah, but the elephant trunk, like those things are, I mean, that's useful. I mean, that's like a third arm.
Yeah, the problem with the neck is I'm already a tall person, and and there's times where that works against me, hitting your head against things and stuff like that. So
okay, try to be tall as a girl. Okay,
that's my preference. I'm already tall, so maybe my wife, she's actually almost a foot shorter than me, so she might want that taller neck. Where
yeah.
But here's the thing, like Rimma, so I don't know how tall you are exactly, but just imagine you have you have a giraffe neck.
I being tall. I am tall. So.
Yeah. Okay. But imagine like you have this giraffe neck, and then you see, I don't know, you're looking like at the top of your cabinets, and it's like, oh, this is dusty. What are you going to do about it? You just can look at
that. That's the side.
It's like a T. You have like T-Rex arms, then relatively speaking. Don't be anyway.
Still, the view from the top is beautiful.
Okay. I like that. That's a good way of putting it. Okay, I will accept that answer. So, Carl, pick a number between 1 and 4.
I'll take 1.
Number 1. Would you rather clean silverware in your mouth as your job, or clean golf balls in your mouth as a job?
At least golf balls. That's dirt. That's outside.
This is
probably
so easy.
Cleaner.
Yeah. Golf balls for sure, right? Assuming it's like the same number. Like I don't. Otherwise, you'd be sick all the time. Otherwise. If you're cleaning other people's silverware with your mouth, the golf balls are like dirt. Like there's nothing wrong with dirt. You can survive dirt. Okay, with that, so Rimma, where can people find you?
So they can follow me on Twitter. It's at Rimma Nehme. And they can also connect to me on LinkedIn account. Twitter, LinkedIn. Also, I would suggest follow at Azure Cosmos DB Twitter handle and the hashtag Cosmos DB for any new things that we light up in the service and any conferences where we are present, or ask us any questions, or just tweet us what you like about the service and what you're building with it. We would actually really happy to see and find out what type of apps you're building against Cosmos DB.
Very cool. So we'll have those links in the show notes along with links to all the other stuff that we talked about. Carl, where can people find you?
You can find me on Twitter at Carl Schweitzer.
And you can find me at ytechie.com or on Twitter, twitter.com/ytechie. So Rimma, thank you so much for coming on here and talking about Cosmos DB. It's very cool.
Thank you so much for inviting me. It's been a pleasure.